Basic electrical meters and meter usage. Meters are a very important tool in the HVAC industry, in many industries, electrical, auto, anything that has to deal with any sort of electrical equipment and wiring. You're going to be required to understand how a meter is reading what is going on in that circuit. So when we are dealing with circuits like this, we need to make sure that we know the meter. We need to understand what that meter is actually telling us. So when we are talking about a meter, we need to understand that the meter is going to be the first tool that any service mechanic is going to be taking out of their tool bag first. It's going to be the last tool that we're going to put away once the job is done. Okay, make sure that we understand how to use the meter. We got to understand and make sure that we read the manual and understand all of its functions. In this industry, we have two types of meters that we are going to run into. We have our analog and our digital meter. The analog meter has been around for many, many years. It was basically one of the first tools on the market as far as meters. They are extremely sensitive and obviously do not stand up very well to being tossed around in a truck or falling off a ladder. So if you do have an analog meter, you got to use some care and making sure that you don't drop it and damage it. Okay, we still use them in this industry today. And when the technician is definitely looking for accurate measurements, there is equipment out there that needs to be functioning and operating within a certain range of voltage that it's actually rated for. So whether maybe within 5–10% of what the actual rated voltage is. Sometimes a digital meter may not pick that up, so you may have to go to an analog meter to kind of get a very, very accurate measurement of what that particular unit is using. We have our digital meters now, which are obviously much more common. Digital meters do stand up much better to being dropped, tossed around in a truck, and they are actually able to take temperature readings. Okay, a lot of our digital meters today are also auto range. So once we do set the dial and we happen to maybe forget to change our setting for whatever reason, it'll automatically do it. The reason why they are much better and more rugged is because a lot of our digital meters now come with a protective case around them. So if they do get dropped, that protective case will protect them. So some basic rules that we need to follow before we even get to understand what the meter is doing. We need to understand basic electrical and the rules that apply to it. Okay, most of these rules are based on voltage and resistance. Voltage and resistance in any sort of electrical troubleshooting are the two most important readings that a technician can take. Okay, without taking a voltage reading, we don't even know if there's power applied to the system. Without taking a resistance reading, we cannot tell whether or not a load or some power-consuming device in that circuit is actually still working. The first topic that we need to understand is series, a series circuit. Okay, sometimes you will hear that technician talk about things in a series with something. Okay, when we hear that word series, it means that they are in the same line next to each other, one right after another. Okay, as you can see in the picture here, we have a high pressure switch, we have a low pressure switch, and we have an internal compressor thermostat. those are all wired in series with each other. So in order for that compressor in this diagram to come on, that high pressure switch, that low pressure switch, and that internal thermostat all have to be in the closed position in order for voltage to even make it to the compressor. Parallel is the other term that you'll hear a lot in many industries. So when you hear a technician speak about things in parallel, he means that they are next to each other. Okay, they have their own line of power and their own lane for things to function. Many things, many loads are wired in parallel. Homes are wired in parallel. Each one of your rooms, your lights, your TV, your vent fan in your house, those are all wired in parallel. If they were wired in series, once you opened up a switch or turned the switch off, everything in the house would shut off. Okay, so in a parallel circuit, each power-consuming device that is in that particular circuit is wired in parallel. So for example, we'll say here, in this example here, we'll say that this light bulb happens to break or die out. The fan motor would still get power, and the compressor motor would still get power. Why? Because we are still receiving its own power supply from start to finish. Our compressor and our fan motor will continue to operate. Even if this light bulb is no good, it's gone. Open circuits is a circuit that does not have a complete path for electricity to flow. Okay, circuits require a source, switch, path, and a load. And if any of these components has a break or an open in it, the current cannot complete its circuit. So in this example here, we have an open switch. This switch is in the open position. When I like to think about a circuit and I hear that term open, I like to think of a switch like a drawbridge. If the drawbridge is open on a highway, traffic stops. Traffic can no longer continue on until that drawbridge closes. So when I see a switch in an open position, my traffic or my electricity is sitting right here until this switch happens to close. And once that switch closes, I can now continue on to my load and complete my circuit. The term open is when you measure voltage across an open circuit, you will always get a reading of source voltage. If we are using a meter, whatever that voltage reading is, if that switch is open, you are going to read source voltage. That source voltage is power that is coming into the circuit. So for example, 24 volts. If my circuit is operating off of 24 volts, if that switch is open, I would read 24 volts across that switch. So when I measure resistance across an open switch, I'm always going to read OL, or open load. That's telling me that the switch is open. I cannot continue on with my path. A closed or complete circuit is one that has a complete path, source, switch, and a load. The load is operational in a complete circuit. Okay, the switch is closed in a complete circuit. So as you can see here, is like I used in my last couple of slides. Here we have 120 volts. I have a 120 volt power source, so if I go across this drawbridge, that is a complete path. Why? Because the switch is now closed and I am now able to energize my circuit and make that fan motor happen to run. When I'm measuring voltage across the switch in a complete circuit, I'm going to read 0. My meter is not going to pick up that voltage because voltage is just like a water circuit. Okay, electricity wants to take the path of least resistance. So when that switch is closed, electricity is going to easily pass through the switch down to my load. My meter will not pick up that difference in potential. It won't pick up anything that's going on. So I'm going to read 0 volts across that switch. When measuring voltage across a complete circuit, I'm always going to get source voltage, or whatever the heck I'm using for my power. Voltage across a load is identical if the load is working or if the load is not working or if it's bad. If you have a switch closed and measure voltage across the load, the circuit is good. If the load is not working, then you have a load that is bad. At that point, we would have to take troubleshooting a little bit further and have to use resistance to figure out exactly where the problem is. Is it a broken wire? Is it the load itself that is no good? If the load is working, then the voltage you read is the voltage that the load is actually using. So when we take current is or amperage, you will measure 0 in an open circuit. The reason why you will read 0 on an open circuit is because, remember, our switch is open, and when the switch is open, voltage is no longer being traveled through the circuit. Everything has stopped. So if voltage stops, amperage will also cease, and my meter will read 0. In a closed circuit, the amperage you measure may change based on where you take your readings. Because you remember, a load has resistance. Okay, when I have resistance in a piece of equipment, I'm going to generate amperage. Wire, the longer the wire is, the more resistance it's going to have. My amperage will be different. So it depends on where I take my readings on a particular load. Many meters out there have these following functions: voltage, current, resistance, capacitance, frequency, and temperature. But it all depends on the extravagant and how much money you want to pay. But your very basic meter will have these certain functions. Okay, voltage is one of the most frequent measurements you take. In order to take your voltage, the first thing we have to do is make sure that the meter is in the on position, and we set it to V, or volts, okay, depending on what your meter shows. You're going to make sure that your leads are plugged into the correct place on the meter. Okay, sometimes if you have them in the wrong leads, it's not going to take the proper reading, or you just might get a scrambled number. Put the leads in parallel next to the point in the circuit you are trying to measure. You're going to hold those leads without touching any other part of the equipment or any other component in that circuit with your finders, okay? And then you're going to watch the display until the meter stabilizes on a number. And whatever that number is, that is your voltage reading. So voltage across an open switch. Remember, voltage across an open switch, you're always going to read source voltage. The reason why we are reading source voltage is because electricity is now going to take the path of least resistance. So since the switch is in the open position, it cannot go that way. It's open. So it's going to come through my meter. My meter will now pick up that difference in potential. So therefore I have 120 volts. Once I close that switch, I'm going to read 0, because now electricity is able to flow through my switch instead of my meter to my load and then back. So I'll always read 0. Okay? So voltage across the non-powered load, you're always going to read 0. Why? Because the switch again, is in the open position. So therefore, all of my electricity is sitting right here at the switch, just waiting to go. So once my meter picks up anything, I will now eventually read some sort of voltage reading there. Voltage across the powered load, I'm always going to read source voltage. Why? Because the load is my power consuming device. So my load and my meter will pick up that difference in potential. So in this case, I'm reading 120 volts. And if I have a bad load or an open load, and that load is no longer working, I'm also going to read a source voltage, because my source or my load is now acting like an open switch. Okay, so power has made it all the way through my switch up to this point, but since it can no longer travel across to my other side of my load, I am now going to read my source, and whatever the heck that may be. When you are measuring across an entire circuit, you're going to read source voltage as well, because it is a complete path. It is a source of power. To measure resistance, you want to disconnect the circuit from the source. Okay, make sure the power is off. With resistance readings, there cannot be any power on the circuit. Okay, if we leave the power on and we're taking a resistance reading, we can fry our meter, damage it in some way. Decide what component or portion of the circuit you want to measure. You are then going to disconnect all the wires from that part, and then set your meter to ohms. Touch one lead directly to the other, and this will show a reading of 0 on your meter. Always test your meter when you're taking a resistance reading. You want to see 0 on your screen, because that's telling you that the meter is still good. If it does not, check your leads for damage and make sure they are plugged into the right spot on your meter. Okay, touch one lead to each side of the component or isolated portion of the circuit that you are testing. Again, wait for that display to stabilize and then record that number. And then again, that is your resistance reading. Resistance is measured in ohms. So, resistance across an open switch, I'm always going to read OL, because the switch is in the open position, OL. Resistance across a closed switch is going to be 0, because my meter is now going to not pick up any sort of difference in that circuit. Resistance across a good load, you are always going to read some sort of resistance number. It could be any number out there, but as long as you get a resistance, that load is still good. If you read OL, switch is open. Oh, that load is open. Somewhere inside there, the wire is broken. Okay? If you read 0 across the load, that load is probably shorted, which means somewhere in there a wire is touching maybe the cabinet or the outside casing of that load, and the load is no good. Okay, to measure current, the first step is to determine which method you want to use. Okay, you can use your clamp-on for higher voltages, or you can use an inline amp meter for taking lower currents or lower voltages. This here is an example of your clamp-on meter. Okay, to make sure you close the switch to energize the circuit when you're taking a clamp-on amp reading. Otherwise, again, if you have no power, you're not going to get any sort of amperage. To measure with a clamp-on meter, make sure that the system is on and running. Clamp the meter around a single wire and wait until the number stabilizes. When you are taking an amperage reading on any circuit, you need to do it one wire at a time. If you try to take an amperage reading over multiple wires, you are not going to get an amperage reading. The meter will actually cancel out and it will read 0. So make sure you are doing it with one wire at a time. And any reading that you take that is an amperage is measured in amps. Okay, for example here, if you have a wire and it's wrapped 10 times around the clamp and your reading is 2 amps, you take those two numbers, you divide it, and in this case it is 0.2 amps. If the current is too low, consider putting the meter in line. Okay, and if that is not possible, you may want to wrap the wire around 5 to 10 times around your clamp on part of the meter if you have to. Do the following math problem and take a reading. Divide the number you get by the number of times the wire is actually wrapped, and you will get an amp reading. However, unfortunately, most of the time you will not just have one switch controlling a load. You may have multiple switches controlling a load. But most circuits in this HVAC industry will have more than one control device. So you must have a reliable, organized method to find problems in that circuit. So we use what was called the Hopscotch method. Okay, this is a good way to start off any sort of diagnostic on an HVAC system, is by using the Hopscotch method. And the procedure is relatively simple. Now, with the Hopscotch method, it is really important to understand that this method only works on 120 volts and below. Okay, so in HVAC, a lot of residential pieces of equipment will work off of 120 volts with 24-volt control circuits. So Hopscotch method is a reliable way of troubleshooting. If you have a 208, 230, 480 system, but the Hopscotch method really does not work so well. You do have to troubleshoot it slightly different. So first, when we are doing the Hopscotch method, you have to make sure that the meter is set to volts, and make sure that the leads are correctly plugged into the appropriate place on the meter. Then next, you're going to check voltage across the two endpoints of our circuit, and in this case, line 1 and neutral, or line to line. Next, you are going to put one lead onto the starting point of the circuit, and in this case, it's going to be L1. And then keep that lead there throughout the entire time that you're troubleshooting the circuit. You are now going to use the second lead to go from point to point in the circuit before and after each switch device and load, and check for opens until you find the problem. So here we go. Here's an example. We have a 120 volt circuit here with a switch and one load. Okay, across L1 and neutral, we are reading 120 volts. That is indicating that we do have power on this circuit. That's a good thing. If we have 0 volts there, that's telling us that we know we do not have power at this circuit, and there's a problem before this circuit. So that could either be a breaker, or maybe the emergency switch at the top of the stairs, something like that. So always make sure you go across the entire circuit first to make sure that you have voltage. So in this case, 120 volts. We are now going to go across. Again, Hopscotch, we leave one lead at the beginning of the circuit, and then we use the other lead to Hopscotch our way through the circuit, one right after another. Okay, so voltage across L1 and the line side of the switch is going to indicate 0. So the wire from L1 to switch 1 is still good. The reason why we are reading 0 is because this is just one wire. There is no break. There is nothing going on. So my meter is going to pick up a 0 in difference in potential. Nothing going on here. If I go across that switch, I am now reading 120 volts. This means that switch 1 is open. Remember, voltage across an open switch is always source voltage. To verify that this is the problem, you can now start from the neutral side. You can do it from the other end of the switch of the circuit on the neutral side. Again, make sure you have 120 volts across L1 in neutral. You are now going to hopscotch to the line side or the neutral side of B1, our load, and we're going to indicate 0. That's telling us that that wire is still good. I go to the line side of my load and I still indicate 0. That's not a problem. Why? Because voltage remains 0. The switch is open. I'm not getting voltage to that side of my circuit. Once I go across my switch to the other side, I'm reading up 120 volts. My problem has been found. My switch is open. Once I close that switch or repair that switch, and I close it, that bulb or that load should come on.